China is not the only nation pushing the limits of construction and engineering. Across the globe, particularly in the United States and Europe, engineers and builders are developing bold new techniques that seem to defy the laws of physics. From 3D printed homes to windows that grow algae to generate heat and even concrete that can repair itself, these breakthroughs prove that modern construction has entered an entirely new era. And some of the most impressive methods are also the most unconventional. But before we begin, don't forget to like the video and subscribe to our channel. Inflatable concrete. Developed by Italian engineer Dante Bini, inflatable concrete structures are buildings shaped using air itself. The process begins with the placement of an inflatable membrane, usually formed as a dome or customized to the required architectural design. Once in place, the membrane is inflated, creating the basic shape of the structure. Steel reinforcement bars are then installed over the inflated form, forming a supportive mesh held in place by the air pressure beneath it. After that, concrete is sprayed over the entire surface, completely covering the reinforcement. Once the concrete cures, the structure becomes fully self-supporting. The inflatable membrane can then be removed, leaving behind a surprisingly strong and durable building. This technology has been used worldwide to construct rapid shelters, particularly for temporary housing and emergency situations. The entire process is exceptionally fast and requires far less labor than traditional concrete construction. Even more impressive, the same inflatable form can be reused multiple times. It is, without question, a unique way of building, just like the next technique, which is transforming bridge construction. Bridge launching. Bridge launching is a remarkable construction method developed by Italian engineer Marco Rossignoli. The process begins with bridge segments being transported to the construction site. These segments are prefabricated in factories with extreme precision, ensuring they fit together perfectly. Once delivered, assembly begins. But instead of building the bridge directly between the piers, construction takes place on solid ground nearby. Next, a launching nose is installed at the front of the structure. This steel framework, composed of beams, provides essential support during the most critical phase. Then, the real spectacle begins. Powerful hydraulic machines, each weighing several tons, lift and push the entire bridge forward. The structure rests on special low-friction supports, allowing it to slide smoothly into position without bending or structural damage. These specialized machines, together with hydraulic jacks, slowly slide the bridge into its final position, pushing it over the supports until it is correctly installed. It is astonishing to see such a massive structure being moved as if it were suspended in mid-air. Once the bridge is in place, the auxiliary structure is removed and the bridge is secured, completing the installation. While smaller bridges can be installed entirely using this method, in the case of larger bridges, the process is usually incremental. Large sections of the bridge are pushed forward while additional parts are attached at the rear at defined intervals until the entire structure is assembled. This process requires total coordination, since a single mistake or misalignment can compromise the entire bridge. Even so, this method is much faster than the traditional technique in which the bridge is built over the span segment by segment. Bridge launching can turn weeks of work into just a few days. Meanwhile, rammed earth construction is an ancient technique for speeding up the building of houses, dating back to the Neolithic period. First, workers create a mold in the shape of the desired structure. Then, soil is placed inside the mold and compacted using machinery or by hand. This process removes air between the soil particles, making the material more solid. The material is added layer by layer, with each layer compacted individually. This ensures that the soil becomes as dense as possible, increasing the overall stability and strength of the structure. When the entire wall is built this way, the surrounding mold is removed, revealing an impressive result. The self-supporting earth structure is extremely durable and can remain intact for many years. In addition, it offers excellent thermal insulation, retaining heat in the winter and maintaining a comfortable temperature in the summer. At the same time, artists have created remarkable structures using this same technique, combining soils of different colors. Kinetic architecture. Kinetic architecture is a type of construction technique that not only looks impressive, but is also extremely functional. Buildings that use this technique feature movable sections or components. These can serve various purposes, such as expanding available space or protecting against harsh weather conditions. One example is the Burke Bras Soleil, installed above the Milwaukee Art Museum. This massive structure opens like the wings of a bird to provide shade for people below, while also acting as a shield that protects the museum from storms. However, this is just one application of kinetic architecture. There are even more fascinating examples spread around the world. For instance, the One Ocean Pavilion is a building with movable facades capable of creating different patterns. The Bund Finance Center features a similar system, in which the facades move in complex patterns, opening and closing parts of the building to accommodate more people. Another striking example is the Al-Bahar Tower, which has a structure similar to a parasol that opens and closes to prevent excessive heat and solar glare from entering. Perhaps the most impressive of all is the Sharifi Ha House, which features rotating rooms capable of expanding the interior space. Kinetic architecture is still a developing construction method, and what we see today is only the beginning. As technology advances, it is impossible to predict what new applications will emerge from this concept. Slipform construction. American architect James McDonald developed a much faster way to erect structures through a technology known as slipform construction. It works as follows. First, a structural platform is built containing the mold of the planned building shape. Next, concrete is continuously poured into this mold. At the same time, the entire formwork structure gradually rises along the building. The concrete hardens, creating a new load-bearing base, and the form continues to rise. It is like a living machine building its own path as it moves upward. This is an extremely fast method for constructing tall structures, taking anywhere from just a few hours to a few days to complete. Even so, this method has some limitations. The mold cannot be modified during construction, which means it can only be used for structures with repetitive layouts. In addition, the entire structure is made in a single continuous concrete pour, which limits the maximum achievable height. This is where another similar method comes into play, known as climbing formwork. This system works in a similar way, but instead of pouring concrete continuously, the form rises one floor at a time. This allows for greater control over the building layout and makes projects with more complex floor plans possible. Although it is not as fast as slipform construction, this method is still extremely efficient for building skyscrapers in a short period of time, with minimal waste and low noise levels. In both cases, the structure rises along the building through hydraulic systems. The entire assembly is driven by multiple hydraulic arms working together, like a caterpillar climbing with its many legs. Luminous concrete is an emerging technology developed in Germany and Hungary that, in addition to being practical, is visually stunning. This new type of cement was created to contain phosphorescent properties, allowing it to glow in the dark. The phosphorescent material present in the cement absorbs light during the day. At night, this stored light is released, creating a captivating glow. Specialists intend to use this unique property for road construction. If roadways glow on their own, drivers will find it much easier to stay in their lanes, reducing accidents. This is not the only application of this technology. The Al-Aziz Mosque in Abu Dhabi uses a similar concept. Lights were placed behind the mosque's calligraphy so that it glows in the dark, adding a new dimension to its beauty. Luminous concrete is an interesting technology that, once perfected, could be present in virtually every home. Developed by ETH Zurich in Switzerland, 3D textile formwork is a relatively new concept designed to easily create curved and complex concrete structures. The process begins with an industrial knitting machine that produces a double-layer textile in the exact dimensions required for the structure. This textile is then stretched and shaped into the planned form using ropes and a contour framework. With this, the formwork is practically ready. Next, cement is sprayed onto the outer layer, thick enough to provide structural support, yet thin enough to avoid adding excessive weight. Once the cement dries, the structure is complete. No bricks or concrete blocks are required. The contour framework and support ropes are removed, and the construction becomes fully self-supporting. And that's not all. This construction method has also proven to be extremely strong. The knit candela, built in Mexico using this technique, was made with a knitted fabric that weighed only about 55 pounds. After completion, the structure weighed approximately 5 tons, fully self-supporting with no need for any additional type of support. In addition to strength, this construction method offers another major advantage. Since there are no rigid molds involved, builders can easily create sharp curves and flowing undulations using the knitted 3D textile formwork. Moving on, we have a new type of thermal insulation that even NASA is using: aerogel insulation. Aerogel is a relatively new material that seems almost magical to those unfamiliar with the science behind it. This material, developed in the United States, is produced using the most advanced thermal insulation technology in the world. But just how efficient is it? It is possible to light a flame directly beneath a thin layer of this material without melting even a piece of chocolate placed on top. These are extraordinary levels of thermal insulation, and this makes perfect sense, since the same substance is used by NASA to protect spacecraft and spacesuits. In addition, aerogel is extremely lightweight. When held in the hand, its weight is barely noticeable, and that is precisely where its application in the construction industry comes in. Currently, aerogels are being used to insulate homes, offering performance unmatched by any other material. They are also used as acoustic insulation agents, reducing noise inside houses. But the advantages do not stop there. Because aerogel is so efficient, only a very thin layer is needed to achieve the same result that would require a much thicker layer of another insulating material. This means the insulation takes up far less space, maximizing the usable area of a home. Top-down construction. Normally, when a building is constructed, work begins with the underground levels and gradually progresses upward. However, a technique developed in the United States completely reverses this traditional concept. Known as top-down construction, this technique consists of building upward and downward simultaneously. Here is how it works. Workers begin constructing the above-ground portion while, at the same time, excavation starts below, creating the underground levels one by one. As the building grows upward, it also extends downward. But how is all of this supported? The answer lies in the gradual excavation process. Each underground level that is excavated begins to provide support for the rest of the structure. The basement slabs act as bracing elements for the retaining walls, supporting the loads. And with each new level excavated, the load is transferred to that new floor. This process is repeated continuously until the entire structure is complete. There are several reasons why this technique has been gaining popularity, especially in urban centers. First, it saves time, allowing the building to be completed in nearly half the usual time frame. Second, there is much less soil movement, which makes construction management easier in dense urban areas. Floating foundations for wind turbines. Specialists from the United Kingdom and Japan have developed a new way to install wind turbines in the ocean. Traditionally, these turbines are fixed to foundations that extend down to the seabed. However, a new method has been created in which the turbine floats. Not like a boat, but in a manner similar to offshore oil platforms. This method uses a semi-submersible or fully submersible base, which keeps the turbine stable and upright in the face of ocean currents. Even so, the base is not free-floating. It is anchored to the seabed by strong cables, preventing it from drifting. But why is this necessary? The world is rapidly moving toward clean energy, and this requires increasingly more space for installing wind turbines. However, the shallower areas of the oceans are not always ideal, whether due to seabed limitations or adverse weather conditions. When wind farms need to be built in deeper offshore regions, this type of foundation becomes essential. Floating foundations represent a major step forward in making wind farms an even more viable solution for sustainable energy. Algae facades. Construction companies in Germany have discovered a much more environmentally friendly way to use building facades, and the result is impressive. Companies such as Solar Leaf are developing facades that have algae growing inside them. By inserting small algae colonies between glass panels filled with water and a small amount of carbon dioxide, they are able to stimulate intense algae growth. But this is not just to give the windows a greenish tint. These algae are extremely useful. They absorb sunlight and, as a result, produce heat, which can be reused to warm the building. In addition, as the algae grow, they can be harvested and converted into biofuel to generate clean energy. And the advantages do not stop there. Algae growth can be monitored and controlled according to the season of the year. In summer, they are allowed to grow more densely, reducing the amount of heat and light entering the building. In winter, growth can be reduced, with the excess being harvested. It is as if they were natural curtains. Not to mention the striking visual effect the building gains both inside and out. Algae facades are an innovative concept that combines natural architecture, sustainability, and functionality. The BIQ house already uses this technology, and considering its benefits, it is expected that more and more buildings will adopt this trend in the near future. Even more impressive is the next innovation, in which the structures themselves are capable of healing cracks on their own. Self-healing concrete. The Netherlands has developed a new type of concrete capable of repairing itself after cracks appear, without losing strength or durability. The way it works is fascinating. This special concrete is produced with the addition of bacteria to the mixture. They act like tiny workers responsible for repairing any cracks that may form. The process is relatively simple. When a crack appears, the bacteria produce calcium carbonate, also known as limestone. This material fills the fissures, occupying all the pores. Over time, the crack becomes completely filled with this whitish substance, rejoining both sides through an agent of natural origin. It is a highly eco-friendly solution. But what are the benefits? Self-healing concrete can be crucial for structures that are not constantly monitored, but perform essential functions, such as bridges or remote shelters. In addition, it is ideal for automatically repairing cracks in hard-to-reach locations, such as the exterior facades of skyscrapers. Amphibious foundations. In regions where flooding is a constant threat, such as Louisiana, builders have developed an ingenious solution. Instead of constructing houses with fixed foundations, they began using amphibious foundations. These foundations are designed to float on water, carrying the house along with them. This way, when flooding occurs, the residence simply floats above the water instead of being submerged. To ensure that the structure does not drift and returns to its correct position once the floodwaters recede, these foundations are anchored. This invention can be decisive in saving lives in flood-prone areas, ensuring shelter for residents even in the worst situations until help arrives. Autonomous construction machines. It appears that even human presence is no longer indispensable for building houses. Companies in the sector have developed robots capable of performing construction tasks in a fully autonomous manner. Each one is designed to specialize in a specific stage of the construction process. There are robots that lay bricks, others that pour concrete, and even those that level materials. There are also window-installing robots and autonomous construction vehicles capable of building roads on their own. Robots are truly taking over the construction industry. And there's a good reason for that. They do not need to rest and can work virtually 24 hours a day, 7 days a week. In addition, they are more efficient, completing the same volume of work in less time. And unlike humans, they do not make mistakes. For construction companies, this represents an extremely advantageous business model. However, there is another invention that is even more efficient and also operates autonomously. 3D concrete printing. Although robots are fast, they cannot compare to the speed at which these 3D printers build houses. By depositing concrete layer by layer, these impressive machines can erect a home in a matter of days, or, in some cases, in just a few hours. The cement used in the process has rapid curing properties, so by the time one layer is applied and the printer nozzle completes a full pass around the forming structure, the lower layers have already hardened and are ready to receive the next ones. The printer itself is large-scale, which is necessary since it must build even larger structures. However, there is no person directly operating the machine. Instead, a set of commands is preloaded into the system, and it simply executes them until the structure takes shape and is completed. Buildings constructed in this way are surprisingly strong and, more importantly, extremely precise, with nothing out of place. Each layer is positioned perfectly, creating an almost hypnotic pattern. Still, although this construction method is gaining popularity and is undoubtedly very fast, does it really compare to the beauty of the next technique, which comes from ancient times? Earth berm construction. The technique of earth berming, or earth-covered construction, has existed since humans first began building shelters, and even today, it remains relevant. The concept is incredibly simple, yet extremely beautiful when executed well. Before construction begins, the site is excavated. After the ground is leveled, a robust structure capable of supporting heavy loads is erected using appropriate supports. Once the house is built, earth and soil are piled over it, covering the entire structure and leaving only doors and windows exposed. And just like that, one of the most ingenious construction methods is put into practice. The benefits of this technique are impressive. The soil acts as a natural acoustic insulator, providing silence and tranquility inside the home. More importantly, it keeps the residents perfectly insulated from external temperature fluctuations. Even during the hottest summers, the interior remains relatively cool, like a cave. During harsh winters, the soil and earth help retain heat as few materials can. However, the greatest highlight is the aesthetics. When vegetation grows over the structure, the house looks as if it came straight out of the Shire from The Lord of the Rings. The integration with nature is extremely soothing. Despite its ancient origins, earth berm construction remains one of the most interesting techniques even in the modern world. Still, if the need is to build houses quickly and efficiently, the next technique proves to be more suitable. Prefabricated modular construction. Who would have imagined that houses could be assembled like Lego pieces? And not just houses, but even skyscrapers. A technology known as prefabricated modular construction, developed by countries such as Sweden, the United Kingdom, and Denmark, has made this possible. This method consists of manufacturing building components, such as walls, windows, and roofing, in advance at a factory. These parts are then transported to the construction site, where they are assembled in a matter of hours. The modules feature design characteristics that allow them to fit together or be connected through specific components. An entire house can be assembled this way, and surprisingly, it offers the same durability as a traditional building. What truly stands out is the speed of the process. An entire skyscraper can be erected in just a few days, and multiple houses can be assembled in only a few hours. At the same time, this technique does not require a large workforce. A small number of professionals can easily assemble a modular structure. In addition, this method significantly reduces waste, since everything is produced efficiently within a factory. And there are virtually no drawbacks. Modular construction represents a true evolution in building methods. Which of these construction techniques do you consider the most impactful? Leave your opinion in the comments below. I'd love to know what you think.